Good morning. Back here with the lesson. Yesterday, you have discussed the OSI architecture. We have discussed, and I have explained you all the seven layers of this OSI architecture and how a subnetwork within a network has a host-to-host communication will play the role, and why only until the network layer it is needed. Now, coming to the next thing which we had discussed, you can have a look on this particular thing. As I have sent already a link to you. As yesterday you have discussed, the physical layer is there only for an raw bits, and a data link layer will be there to whatever a stream of bits will be there, it will aggregate and it will make as an a frame. I told you yesterday, and a network adapter, whatever will be there, that protocol will be there, and it will help in host to host communication. As I told you yesterday, network layer will be there for a routing among the nodes on packet forward network, that is store and forward network. So the unit of data exchanged, we call it as a packet, which will have its own new identification. This also I told you in a last class. Now transport layer implements a process to process channel. As I told you that whatever entire message of stream will be there, that is a packets, unit of data exchanges in this layer is called a message. So entire 100 packets, 1 to 100 packets will make one message that will be exchanged. So session layer will be there, where tie together the potential difference of a transport layers. That means a name will be given for that, and entire session will be maintained in a namespace. Now I'm concerned about the format data exchange between the pairs. As I told you that network coding to the yours own OS representation, it will converts. Then this will be connected to the user. According to the application, the data will be represented to the user. So that we had discussed. Now we'll go with the today's topic, that is a TCP IP architecture. Now in this particular architecture, we'll have four layers that you have to keep in your mind. And one thing I'm very clear here, that TCP IP layers or TCP IP architecture reference model is there before the OSI reference model. When IOC, International Standard Organization, has proposed this, before that the TCP IP is there, but in pledge they want to use all the seven layers. They feel like that the complexity can be reduced. But later on, they have come back to the TCP IP architecture or on a reference model. Why? Because the layers are less, and here the layers, whatever layers work function is there, we can merge with together. Now you can observe how I will compare the OSI reference model with this particular internet model. Now you can see this application layer is there. Here the application layer is a combination of all our other two layers, that is an session layer and a presentation layer. The session layer work and a presentation layer means a session name will be given, a session name will be maintained until the entire process. So that will be done with application only, and then the presentation converting from network codec to the application codec, it will be done by application layer only. Now only one layer will be there, that is application protocol will be there, which will look after all these protocols work. Now coming back to here, what are these protocols which will play? You can see the protocol graphs in that particular application layer, that is an FTP, HTTP, NV, TFTP, like that different protocols will be there. For example, yeah, FTP means file transfer protocol, HTTP, you know that, hypertext transfer protocol, and like this different protocols will be there here, which will make connect to the user, and it will make the work of that three layers. Coming to the next layer, you can see here the transport layer. Here in this transport layer, we are having two protocols. You can observe here, one is a TCP and another one is an UDP. That is, the TCP is a transmission control protocol and user datagram protocol. Two things will be there. What is this actually? See, as I told you that the process to process communication will be there, whereas 100 packets will be there. Either all 100 packets are moved or not, that you have to check, and acknowledgement either packet reached or not. In between any packets dropped, how you will come to know this? So all this work will be done by this TCP. This is a reliable protocol. For example, I'll tell you, the work of this protocol will be like this. It will be reliable. How I am telling that it will confirms whether the packet has reached to the destination in that particular sequence or not. If it is not reached, the retransmission process will be done here. How that things will be done, we will discuss in the coming chapters. How an acknowledgement from a destination side will come based on acknowledgement, how the retransmissions will be done. So this is a TCP which will do all this particular ones, and you will get a doubt that why this another one is there. There's an UDP, the user datagram protocol. What actually this particular protocol will do, no? User datagram protocol actually meant for an audio and a video streaming files. Here actually to say the reliable is not important, it's an unreliable protocol. What's an unreliable protocol? Here acknowledgement concept will not be there, but it should maintain a jitter factors here. That is, it should maintain a latency, and the latency should be very less here. That means the delay should be very less here. For example, assume if I want to download an one particular video, if it takes a more time, assume that I'm going with one telecommunication company SIM, and I'm having an internet. So in the internet, if buffering takes more time, I will tell no, this network is not good, correct? No. So here, rather than the packet sequencing, as in beginning classes I explained you that one video will need a several frames, and several frames will makes several data. So in that different packets will be there in one videos. Here and there packets are missing, not an issue, but the time maintenance between the time interval maintenance between the packets is very much important in this particular UDP protocol. Here these two protocols are meant equal to the transport layer protocol and a OSI model. Coming to the next, you can say today entire world is depending on this particular protocol, that is the internet protocol, IP protocol. It's equal to your network protocol, what it will be there. And now you can see here the IP protocol, whatever is there, it will do the first task of an IP protocol is identifying a packets with a unique address. This is the first one, rather than then maintaining a route from source to the destination. How from source to destination the route will be maintained, that thing will be taken into the consideration by this particular IP protocol. Now whenever a route failures will occur, how the rerouting of that particular will be done, all these particular things will be done by this particular IP protocol. Here the packets will be tracked from source to the destination, either the packet is gone to the destination correctly or not. Coming to the next subnetwork layer. In this layer, again protocols, different types of protocols will be there, net 1, net 2, net n, depending on your networks. Here this is a combination of data link layer as well as a physical layer. Both layers clubbed together, we'll call it as a subnetwork layer. And based on your networks, that is either you are having a Ethernet LAN connection is there, one protocol will be needed. For example, I can say 802.3 like that. Wi-Fi can be there, Bluetooth can be there, or OFC connections can be there. Based on the network, here this particular layer will work. And here this is a host to host communication, as I told you, data link layer in OSI model also. And here the subnetwork layer is meant with a host to host communication, and it will works with a physical address of one system to the another system. In our type we can call it as a MAC address also. That is how the one system is connected to another system, and how a frame can be transferred from this system to the neighbor system. So in this way, this TCP IP architecture will work with the different protocol graphs. In exam, you will get a question that explain TCP IP architecture with a protocol graph. So if the question is there like this, around they can ask for a 8 to 10 marks question they can ask, and this is a very relevant thing for exam, as I told you that how the